Two apps, same C# code. One runs only on Windows and the other runs on Windows, Linux, and macOS out of the box. This is WPF versus Avalonia UI, and by the end of this video, you will know exactly which one your next project should use. I have built the same inventory dashboard in both frameworks side by side so that you can see the real difference and not just the theory but the actual code. Welcome back to Vector Art, where we build polished .NET UIs trying to minimize third-party libraries. I'm Ranak, and today we are doing one of the most requested comparisons on this channel. So stay tuned. And if you haven't subscribed to my channel, please do subscribe to my channel. It means a lot. It motivates me to create more such videos. Here's what we are going to cover today: the philosophy behind each framework, the project setup, how it is actually different, the C#, the XAML syntax differences that will make you think, and then the view models. We'll compare the INotifyPropertyChanged versus the ReactiveUI, styling, resource dictionaries versus Avalonia styles, cross-platform, what Avalonia can do that WPF cannot, and the honest answer, which one you should use in 2026. WPF, or Windows Presentation Foundation, shipped with .NET 3.0 back in 2006. It brought GPU accelerated rendering, XAML driven UI, and the MVVM pattern to the Windows ecosystem for almost 15 years. It was the way to build serious desktop Windows applications. On the other hand, if I go to Avalonia, Avalonia started as a community project around 2013. The idea was simple: take everything developers loved about WPF and make it cross platform. Version 11, released in 2023, hit a stability milestone that made it production ready. Today, it powers real enterprise apps on Windows, Linux, macOS, and even web via WebAssembly. I have made a separate video explaining how the WebAssembly works. Please do check it out. I will leave a link in the description. So here's the 30-second comparison before we get into the code. WPF is Windows only, ships with .NET, mature ecosystem, huge Stack Overflow presence. Avalonia is cross-platform, NuGet packages are present, modern reactive patterns, and growing fast. Now let's open Visual Studio and see what this actually looks like in practice. I have set up single solution with 3 projects. Let me walk you through the structure. InventoryPro.shared. This is the standard .NET class library. It contains our product model and the relay command. Both the WPF and the Avalonia reference it. Here you can see in the dependencies under projects, you have the InventoryPro.shared as referenced. And here, even in the dependencies of the Avalonia project, you will see this same referenced. So yeah, that is the references, and this is the whole point. Your domain logic doesn't change between frameworks. Let's now look at the InventoryPro WPF project, and you will see that it targets .NET 8-Windows. This -Windows suffix is everything. It's what gives you access to system.windows and the WPF assemblies. This project cannot be built on Linux. Now, if I take a look at the Avalonia project, you will see that it targets .NET 8 plain, no platform suffix. It also targets .NET 8-Windows. If you want a Windows specific build. The key packages are Avalonia, Avalonia.desktop, themes.fluent, ReactiveUI, and these provide all the necessary tools for building this Avalonia project. One thing to highlight or note is Avalonia comes in via NuGet. WPF is baked into the .NET SDK. So Avalonia will add to your project restore time and your published app site slightly. Small trade-off worth knowing about. Difference that you will hit is how the app starts. So in WPF, you have the App.xaml, and let me open that up, and you will see that we have this startup URI pointing to our main window. The framework wires everything up for you, clean, familiar, and little magic. Now in Avalonia, we have the Program.cs and a proper entry point. You use the builder pattern, appbuilder.configure, use platform.direct, detect, and use reactive UI. These are more explicit, more testable, and gives you finer control over the startup pipeline. If you focus on this use platform detect, is doing something really interesting. It's selecting the correct rendering backend at runtime. On Windows, it uses direct 2D. On Linux, it uses X11 or Wayland. On macOS, it uses Metal. One binary, multiple rendering backends. Now the part developers care most about, the XAML. Let's go line by line through the differences. First things first, if I go to the views, you can see our WPF uses a different extension. WPF uses .xaml, and if you see Avalonia, you will see that Avalonia uses .axaml. The A in Avalonia's convention is to differentiate its files. Your tooling won't confuse them. Next is the namespaces. So let me open the main window.xaml, and you will see here on the top, WPF uses the classic namespace, which is the XAML/presentation, whereas Avalonia uses the GitHub namespace. So if I go to the main window.axaml, and here you will see that the namespace that is being used is github.com/Avalonia UI. That is what tells us the XAML parser or the XAML parser which control library to use. Here's the biggest one. Avalonia supports compile time binding via X data type, and WPF uses reflection based binding at runtime. Compile time bindings give you IntelliSense in XAML, compile time errors for typos in binding paths, and better performance. And you can opt it in every file. So if you want to know more about this, I have made a separate video of which I have put a link in the description, where I have explained how this compile time binding works by used by this X data type. So next one is to check the layout syntax, which is almost identical, which both projects both frameworks use, which are grids, stack panels, and dock panels. All work the same way. Avalonia adds a shorthand. You can write column definitions as inline attributes. For example, if I go to the axaml file, you will see that we have written the column definitions inline over here, and not the same way as you write column definitions in WPF. Next one is the spacing. So spacings on stack panel is achieved by using this property called spacing, whereas in WPF you need to use or space stack panels by using margins on each child or a custom panel. Avalonia borrowed this from modern XAML platforms, and it's genuinely better. Now for the most visually striking difference is styling. So in WPF you apply styles with style equal to static resource and the resource name. But in Avalonia, for example, here I am in the main window.xaml, and here you can see I have applied this style to this text block, and the style is equal to the static resource and the resource name. But in Avalonia, you can add CSS-like styles. And if I go back to the AXML file, here you will see that we have made use of classes, and here you can see this button has this class set to accent, and the second button has this class set to ghost. So your style sheet then uses a selector like the button.accent, and exactly like CSS, this makes styling composable. One button can have multiple classes. Let's look at how each framework handles themes. So in WPF, we have resource dictionary. So let me open the assets folder, and here we have themes, and here you can see WPF uses resource dictionaries, and this is a classic approach. You can define solid color brushes with X key names and reference them anywhere with static resource or dynamic resources. To style a button in WPF, you can write control templates, and it's verbose. You are retemplating the entire control, but you have the total control over every pixel. But now let's switch to Avalonia, and here under assets, you have themes. And in Avalonia, the theme file is a style element. So not resource dictionary. You can still define resources, brushes inside style.resources, but your control styles use CSS-like selectors. So if you focus on the button accent, I can scroll down to the same example like the themes that we did for WPF. So here you can see the button accent, and here is the selector button.accent, and the selector means any button with this class accent. And look at the point over pseudo class at the bottom over here. So this selector will be replacing the triggers. So WPF uses triggers for this, and Avalonia uses these pseudo classes. So Avalonia uses selectors that compose just like CSS pseudo classes. The functional result is identical, same dark. If I go back to the window over here, you will see that it's the same dark navy theme, same blue accent, same rounded corners, but the Avalonia version is shorter and easier to maintain as your app grows. That selector system really pays off at scale. Now let's take a look at the view models. So WPF view models, if I open the view model over here, you will see that it implements the interface INotifyPropertyChanged, and write the event, write the onPropertyChange helper. It's a boilerplate, but it is explicit. Avalonia view model with reactive UI, you will see the change instantly. So if I go to the view model over here for Avalonia, you will see that it takes a different approach. So here you can see it is inheriting from the reactive object, and instead of implementing it from the INotifyPropertyChanged manually. Reactive UI and this when any value replaces WPF's update source triggers and data triggers. So the actual business logic is identical to the WPF view models, reinforcing the point that XAML frameworks share the same C# layers. Next is the commands. So if you take a look at the commands are in the reactive UI, you will see that the reactive UI really shines. In WPF, we use relay commands from our shared project. So here you can see in our shared project, we have created this relay command.cs, and WPF is basically using the relay commands from our shared project. It works fine. In Avalonia with reactive UI, you use reactive commands. So here you can see we are not using relay commands, but we are instead using reactive commands. The huge benefit is can execute is an I observable, a reactive stream. Here we use can delete, watches the selected product property and automatically emits true or false whenever it changes. No manual raise can execute changed calls needed. Next, one thing I would like to highlight is the when any value. This you can read as, for example, this whole line, you can read it as give me an observable that emits whether selected product is non-null. This is reactive programming model. It is a learning curve, but once it clicks, it eliminates the whole class of bugs. And here the load seed data, apply filters, delete product are methods that are byte to byte or byte for byte identical between the two projects. That shared project is doing its job. Then let's move to cross platform. So let's talk about the elephant in the room. So here if I go to the Avalonia project, you can see it, of course it is built for cross platform support, and the same app, the same XAML, the same view model, but it will run on every OS that is listed over here, be it Windows, Mac OS, Linux, iOS, Android, and even WebAssembly. I've made a video on how to run this Avalonia app on WebAssembly. I'll leave a link in the description. Please do check it out. For WPF, this simply doesn't compile outside Windows. That's not a criticism. It is design's choice. WPF was built for Windows, and it does that Windows beautifully. But if you are a user on Linux or Mac OS, WPF is not your answer. Avalonia 11 supports Windows, Linux via X11 and Wayland, Mac OS, iOS, Android, and WebAssembly. One code base, generally all of them can be used using the Avalonia. Mobile support is still maturing, but the desktop is rock solid. All right, the honest answer: use WPF if your app is Windows only, and that's a hard requirement. If you are maintaining an existing WPF code base, use WPF. Your team already knows WPF and the deadline is real, then choose WPF. And if you need the absolute widest stack flow overflow coverage for every edge case you will hit, then use WPF. Choose Avalonia if you want a cross-platform app and it is a requirement or a nice to have. Choose Avalonia if you are starting a greenfield project in 2026. Choose Avalonia if you want modern tooling like compile bindings, reactive UI, and rider support. Choose Avalonia if you are building something that might eventually target Mac OS or Linux. And yes, if I know you are thinking, what about Maui? That's a separate video that I've already made, linked in the description. Maui is different beast, mobile first with desktop as a secondary target. Avalonia is desktop first. They serve different use cases. The source code for the entire solution, both projects, both XAML and the shared library, is linked in the description. So if you click on it, it will lead you to this page where I have the GitHub repository present. Download it, both apps, and see the difference for yourself. If this video helped you, leave a comment below, WPF or Avalonia, which are you going with? I read everyone. If you are new here, the WPF versus Maui video tutorial are worth watching. So I will leave a link to it in the description or at the end screen. Thanks for watching. Vector Art, build something polished. I'll see you in the next one. Till then, bye bye.